Hi there and welcome back to the M5 Stack official channel. I'm Luke and it's that time of month again where we're going to take a look at some of the new products in the M5 Stack range. First up, we have a bunch of existing products that have been upgraded or added new functionality to. I'm sure a lot of you are excited about the Core 2. The Core 2 has been in development for a while and adds a much requested feature to the Core that a lot of you have been asking for, which is a touchscreen. Besides this touchscreen though, what other functionality does the new Core 2 have? If we look around it, it looks quite familiar compared to the original Core. Stacked side by side with the original Core, they're more or less the same in height as well. On the side though, here we can see that it's got a dedicated power button and a dedicated reset button, instead of having it in a single button like in the original Cores. It still has the familiar SD card and microphone holes, but there's also been added a vibration motor. What about the chips inside? So it's using the ESP32 D0WQ6 version 3 chip. Previously we were using the IP5306 for the power control chip, but there was a lot of issues with that in the past of not being able to go into deep sleep or being able to get accurate readings of a battery. So that has been replaced now with the AXP192, which is also used in both the Stick C and the Stick C Plus. It has 6 megabytes of flash and 8 megabytes of PS RAM. So then it's quite similar to the Fire in terms of processing power. So the screen itself, the original Core was using the ILI 9341. This touchscreen model is the ILI 9342C. It still has the original 1 watt speaker in there, but an improvement on this side of clarity due to using an I2S power amp which is built in. There's also been an upgrade on battery, going up to 390 milliamps in this particular battery. If we look around to the back, it's a little different than what we might have been expecting. So we know that the original Core had the GPIO pins laid out around the sides, and it would still be possible to use that base. But this base is sort of flush with the case of the M5 Stack Core 2 and can be removed as usual. But what's different here is we have this expansion slot here. So this is a new feature, and there are likely to be a bunch of different expanding sockets. So whereas the original Core had the gyroscope sensors built in, they are now in this little section here. So we have the MPU 68A6 inside and the PDM Mic SPM 1423, and they're both in this little slot here. It also has a built-in RTC. It's using the BM8563 chip. If we look around to the side also, there is a charging LED. So now we're not left guessing whether the battery's charged or still in the process of charging. And here are some of the other specifications of the device. We'll have a quick peek inside the device, and I'll be covering more about the Core 2 and some of the exciting software that's been developed by some of the beta testers and other users in another video. On to the next device. Here we have the Bala 2. The M5 Stack Bala was originally a balancing robot which used the Fire which slotted on top of the device using pogo pin connectors. Now this is a mounted device, so it's using the core gray device in the top there, but it essentially functions as if it was the M5 Go, since there are the two extra growth ports on the side there, which would have been on the Go or Fire. What it also adds is 4 extra servo pins on the side there, and if we open up the device, there's also 4 extra servo mounting pins on the inside. Another big difference in the M5 Bala 2 is the battery level. This is using a 1200 milliamp hour battery. It has a built-in MPU 6886 gyro sensor and also the BMM 150. So it has these 2 DC motors here for the wheels, which are also have an incorporated encoder. The main drive chip of this chassis is the STM32 F030, and another notable feature is it's also got lots more points where you can connect your Lego to. I can see this being used in a lot of Lego based robots. So here's a bunch of the other specifications for this device. And I'd love to see stacking some of the other modules, perhaps a GPS module, into this new style Bala. And hopefully we'll have a video on that in the future. Okay, so let's have a look at our last product that is an upgrade of one of our previous products, and that is the Rover C Pro. Now the Rover C came out quite a while ago. It must have been around this time last year if I remember rightly. And if we open up, we can see there are a few differences here. Most notably, there were some issues of power management in the original Rover C. One of the biggest issues I found was the battery wasn't removable, and so that's not an issue this time. There is a lithium-ion battery in the base, which is the 16340, and that can be removed. And it's also using the same control chip, the STM32F030 chip in here. It has 2 extra servo ports on the top here, which brings us to its most unique feature compared to the old version. One of the most notable features of this new Rover C design is that it has this mounting plate on the front with a nice little gripping mechanism there that we can use one of these 2 servo channels to control. The other servo channel could be used for all kinds of extra add-ons, whether you wanted to add another robot arm or make an extension of it. So aside from that, not much has changed, although it does seem that the build quality of this chassis has been improved somewhat. And it's both compatible with the Stick C and the Stick C Plus. So let's have a look at some of the specifications of this device. And there we go. Hopefully we'll be doing some videos of that in the near future, so stay tuned. So aside from these new upgraded devices, what else have we got for you? Well, in particular, there's some devices here, 3 devices specifically, that are focused on measuring both current and voltage. First, we have this Proto Meas, which is short for measure. This kit is specifically for measuring both voltage and current, but to be specific, it is a Proto kit. So it is basically a breakout board or a breakout module with the case there. The case is 13.2 millimeters in height, so plenty enough space to fit a bunch of components in there. So this kit would come with everything that you may need to develop some sort of current and voltage measuring device. It has the two plugs for multimeter probes in there, and also the pin header for slotting into the M5 stack core. And alongside that we have the two probes and probe leads. Aside from that, we have the V meter and A meter. V meter for voltage and A meter for current. They're both using the same 16-bit ADC, which is the ADS1115. You can check the datasheet for that in the docs page. They both have isolated power circuitry built in there for reducing noise. We can see some of the specifications of all three of these devices over here. And as I said, make sure to check the docs pages too. Following on from that, we have our last bunch of little devices. One more kit for the Atom series, although this particular device has been designed specifically for the Atom light. It's a step motor driver. I think perhaps the reason why it's only used for the light is that the RGB LEDs maybe draw too much power when the step motor is also running. If we lift off this Atom light, we can see here there's a dip switch. This is for altering the micro stepping. And under the casing here, we'll find a potentiometer for adjusting the current, which can be maxed up to 1.2 amps. The specific chip that it's using is the DRV8825. It has a status LED built in, it has overcurrent protection built in, and it's generally advised that you would use external power for the stepper motor that you're using. Any kind of NEMA stepper motor or smaller models of stepper motor should be able to work with this device. And hopefully we'll have a video in the near future of using this to control stepper motors. So stay tuned for that. Some of the specifications for this device we can see over here. Okay, last but not least, we have a new series of mini units. So these mini units, some of them have similar functionality to some of the M5 stack devices that we've seen in the past. For instance, we have this acceleration and gyro unit here. Compared to the regular units, it's quite a bit smaller and sort of in this square form factor opposed to the previous longer rectangles. So this particular device is IMU, which is using the MPU 6886, which is incorporated in a lot of other M5 stack devices, particularly the cores and the Stick C. But say you're using the Atom Light or the Stick V devices which do not incorporate those sensors, these can easily be extended from the grove port of the device. It even has a cute mini grove cable in there to go with its size. Also, this specifically has been requested for industries such as fashion tech or motion tracking, where users wanted to have an external accelerometer disconnected from the main device, and even to chain multiple of these IMUs together with the Grove T connector that we also sell. We also have the barometric pressure sensor, which we've seen a similar unit to this before. Some of the main core devices also feature this sensor, but as I was saying before, this is generally for external or for using with cores that don't already implement those sensors. So this is using the BMP 280, which is a barometric pressure sensor, and it has a range of 300 to 1100 hectopascals. It has generally, give or take, a meter or so of accuracy, and it also has a built-in temperature sensor. So you could compare this to maybe the ENV sensor, but in a much more compact package. Lastly, we have these two new units. So this is the PDM Microphone unit. So this is using the same microphone as in the new Core 2, which is the SPM 1423. Again, if there is devices, specifically say the Atom series, which do not include a microphone, this is perfect to extend that functionality. And this PDM microphone really is got a nice high signal to noise ratio, high sensitivity, and using very low power. So excited to see what kind of applications, maybe audio related audio capturing projects that you may do with this unit. And lastly, we have the TVOC ECO2 unit. So a few acronyms there. The TVOC stands for Total Volatile Organic Compounds. So this is for measuring certain volatile organic compounds. ECO2, the equivalent CO2 level. So this is essentially a gas sensor, which is using the SGP30 sensor inside. You can see here the specifications of the particles per million and so on that this particular sensor can sense in your environment. So this is all the devices that we're going to introduce today. Now let's have a brief overview of some of the applications and how to get set up with some of this new kit. Let's take a look. So let's first see how to get set up with the Core 2. If this is your first M5 stack device, make sure to install the CP2104 COM port drivers. If you've already used Core 2 in Arduino, you'll have the board definitions installed. If not, make sure to go to the quick start pages on the docs. So we can choose the device as a regular M5 core, and then we go to the libraries and search M5 stack, and you can find the M5 Core 2 library there. Currently there are only a handful of examples to try out. One of these is the simple touchscreen test that we see here. On a side note, some of you may be wondering whether the previous modules fit into the new Core 2. I tested this USB host module and it fit rather loosely, but the GPIO base of the original core fits in quite snugly, and you can see it booting up from the internal battery here. For those of you who prefer UI Flow, all we need to do is open up the UI Flow desktop IDE and go to the M5 burner. Here we can see the factory test that we already have on there, so don't worry about losing that program. And there's now a better version of the UI Flow firmware for the Core 2. So let's flash that and give it a quick look. It's a nice clean interface here, and we can see the superior resolution of the screen. You can navigate through by tapping in the apps. There's this nice little color swatch demo. We can go through to set up for either USB or wireless settings. And if we click on the settings there, we can also see an information page. So nice little interface there. Let's take a look at the new version of UI Flow. There's been a slight change here to the setup with some nice graphics for choosing which core device we are going to use. The first thing you'll notice in the UI Manager is that we have a whole bunch of new functions that we can add in for adding buttons and sliders and all kinds of UI interface elements to the screen. Let's run this program and see how these new elements function. The interaction with these widgets feels super smooth, and I look forward to seeing what kind of new interfaces will be developed using these new tools. A short while ago I found that the little VGL platform had been ported to the M5 stack. A quick scan of the flash of the device reveals that it's using the little VGL library. We'd like to give a big thanks to the little VGL team for the hard work that has made this great interface possible. As for the Bala, it works straight out of the box. All you need to do is turn it on and it will start to write itself. If you want to charge this device, make sure to leave it upside down, as it automatically kicks into the program as soon as you turn it on. As for the units we featured, only the IMU and barometric pressure sensor are currently available. I'll have a look at doing a video on these when they become available in UI Flow. Rover C Pro operates very much the same as the original Rover C. And a quick look at the documents, we can see there is an easy loader for a sample program and some sample sketches in UI Flow. And that's about all we have time for in today's new product introduction video. Hope you got a clear overview of what these new products are and what features they have. If you have any more questions, don't forget to leave them down in the comments. As always, please like and subscribe, and I'll see you in the next video. Goodbye.